This is a United States aircraft carrier strike group. It represents the pinnacle of technological sophistication, capable of projecting global power. Yet in the modern Middle East, this immense force is currently stalled. Firepower alone has failed to secure these maritime routes. The U.S. military possesses more destructive capability than any other force on Earth, but it is currently grappling with an adversary optimized for speed and disruption. The gridlock is the result of a mismatch in tempo. A rigid, technologically supreme conventional force is being outpaced by regional actors designed to prioritize rapid, erratic movement over sustained combat. To understand how a smaller force achieves this, we have to look back at the origins of maneuver warfare theory. Specifically, we need to examine the work of Colonel John R. Boyd, a military theorist who analyzed the mechanics of air-to-air combat. When we apply Boyd's thermodynamics of conflict and time to the current crisis, the nature of the standoff changes. We stop looking at static troop deployments and start seeing the mathematics of chaos. This is a Soviet MiG-15. During the Korean War, Boyd studied the engagements between the U.S. F-86 and this aircraft to determine what produced a victory in aerial combat. His study revealed that the victor was rarely the fighter with the highest top speed or the most armor. The advantage belonged to the aircraft capable of executing what Boyd termed fast transients. A fast transient is the physical ability of an aircraft to rapidly shift its energy states. By losing and gaining energy faster than the opponent, a pilot introduces sudden, unpredictable ambiguity into the fight, forcing the adversary into a continuous state of reaction. This diagram outlines the cognitive equivalent of those physical transients, the OODA Loop. It maps the 4 stages of the decision cycle: observe, orient, decide, and act. The core operational mechanism of Boyd's theory is simple. If you can compress your own decision cycle while stretching out your adversaries, their entire operating system collapses into confusion. Victory is achieved by forcing the adversary to process ambiguous, rapidly changing data until they are mentally paralyzed. You defeat them by outpacing their ability to understand the environment. Boyd traced the concept of fast transients backward through military history, identifying a consistent reliance on deception and swiftness. He grounded his historical analysis in the ancient Eastern tactical concepts of Cheng and Ch'i. Cheng represents the orthodox, direct application of force, while Ch'i represents the unorthodox and unpredictable maneuvers. This is Boyd's original diagram, analyzing the Battle of Marathon in 490 BC. The dashed outer arrows represent light troops acting as the Ch'i, swirling to unmask enemy dispositions. The solid blocks are the heavy troops, the Cheng, hurling their strength directly into the resulting weaknesses. The interaction between the swirling light forces and the heavy, rigid mass generates systemic chaos. This constant stream of conflicting information compromises the adversary's capacity to orient themselves to the true threat. This geometric relationship between rigid conventional mass and swirling asymmetric chaos is scale invariant. It operates on the same mechanical principles today as it did in 490 BC. This map abstracts the modern Middle East to mirror the marathon diagram. The U.S. and Israeli militaries operate as the heavy Cheng elements, relying on massive, static infrastructure. The adversary acts as the Ch'i, using dispersed, low-cost drone swarms to strike from multiple vectors simultaneously. Because these asymmetric strikes occur with high frequency, they continuously cloud the observation and orientation phases of the U.S. command structure. The conventional forces are forced to process an endless stream of ambiguous threat data. A technologically superior force is finding its offensive options narrowed by a much weaker but highly ambiguous enemy. The U.S. and Israeli militaries are currently reacting to a tempo dictated by their opponent. This reactive state is the result of a specific logistical imbalance that we can measure in real time. We can calculate exactly when and how this conventional OODA loop freezes. The gridlock is enforced by a quantifiable logistical constraint, interceptor depletion. This chart illustrates the collapse. The U.S. military holds a maximum regional defensive inventory of roughly 8,000 interceptors. Against that static defense, the adversary's offensive inventory includes an estimated 45,000 ballistic missiles and up to 150,000 unmanned aerial systems. This photograph shows a lineup of Iranian ballistic missiles. These are mass-produced munitions explicitly designed to saturate defense networks. The mathematical outcome of this imbalance is certain. In a sustained exchange, the defender will exhaust their 8,000 interceptors long before the attacker runs out of low-cost offensive munitions. When incoming vectors outnumber defensive capacity by an order of magnitude, the defender's OODA loop fully freezes. They are forced into a purely reactive posture, losing the capacity for independent strategic action. This localized military paralysis immediately threatens a global economic vulnerability, the Strait of Hormuz. This is Karg Island, Iran's principal facility for petroleum exports. If conventional forces attempt to break their strategic gridlock by kinetically escalating the conflict, for example by striking this facility, the outcome is highly predictable. The adversary has signaled a guaranteed countermove. They will destroy the oil extraction and refining capabilities across the entire Gulf region. This map highlights the global exposure to a prolonged closure of the strait. Japan relies on the Persian Gulf for roughly 75% of its oil. South Korea requires 68%. Both India and China source over half of their petroleum from this region. A sudden, indefinite halt to these shipments would cause Eurasian energy prices to skyrocket. Global manufacturing supply chains would grind to a halt, triggering a collapse of industrial production at a scale not seen in nearly a century. The disruption of this single maritime choke point mathematically guarantees a cascading failure of the global industrial economy. This unwinnable geometry leads political analyst Rostislav Ishchenko to propose a darker hypothesis regarding Washington's grand strategy. Ishchenko suggests the U.S. may be prepared to deliberately plunge the region into large-scale military chaos rather than attempting to maintain an insecure peace. There is a ruthless logic to a scorched earth approach. If a retreating superpower can no longer securely control a vital global logistical hub, it can deny that hub to others by making it unusable. A prolonged conflict in the Middle East would trap Russia and China in the economic fallout, starving their industrial bases of energy and forcing them to expend resources managing regional instability. In modern grand strategy, overwhelming chaos functions as a weapon in itself. Just as John Boyd observed in The Skies Over Korea, collapsing an adversary's operating environment is often more devastating than meeting them in direct conventional warfare.